Alright, and we're back with lesson 57. We are doing operations with small numbers in scientific notation. And your one objective is right here, so let's get started. Now, remember we did operations with big numbers in scientific notation. Okay? Nothing changes here. We're going to do this the same way, okay, with small numbers in scientific notation. So, example 1 says if a sheet of notebook paper is 1/100th of a centimeter thick, how tall is a stack of 2,500 sheets of notebook paper? And it says first we want to express each number in scientific notation and perform the calculation in scientific notation. Okay? Well, what I'm going to end up doing is if I want to know how tall that stack is, I've got each sheet is this much, and I've got this many sheets. I'm going to multiply those. Okay? So I'm going to take 0.01 times 2,500. Now, they want us to not solve this way. Okay, they want us to solve it using scientific notation and write our answer in scientific notation. Okay, so the very first thing I have to do is express this number in scientific notation. Well, remember, scientific notation is some number between 1 and 10 times 10 to an exponent. Okay, well, here I know my number between 1 and 10 is just going to have to be 1. Okay, so it's going to be 1 times 10. And if I were to put my decimal point in here, I'd have to move it twice to the left. Okay, so that's to the -2nd power. And we're going to multiply that by this number in scientific notation. Well, again, number has to be between 1 and 10, so that's going to be 2.5. We'd put our dot right here. Times 10 to the 1, 2, 3, that's positive 3rd power. Okay, now we're going to just perform the operation like we did before. Okay, so the very first thing we ever did on these is multiply the two number parts together. So I'm going to take 1 times 2.5. Okay, so I'm going to take this times this, and that's going to be 2.5. We're going to write it times 10. And then we're multiplying. So remember what we do with these exponents when we multiply. We multiply the numbers, we're going to add the exponents. So I'm going to have that to the -2 plus 3 power. Okay? Now I can't leave it like that. I need to write it as just a single exponent here. So I'm going to have 2.5 times 10, and then -2 plus 3 is +1. Okay? Or I could just say it's 2.5 times 10. Okay, and it's centimeters. So we can leave our answer in scientific notation for these. Okay? If we didn't want to leave it in scientific notation, then we could say 2.5 times 10 to the first. That's the same as 25 centimeters. Okay? But let's leave our answer in scientific notation for these purposes. Alright, now we're going to go on the next slide. We're going to go through 4 more problems like these, and then we'll be done. So, example 2 here. We're going to perform part A in scientific notation. So we had 2.4 times 10 to the -6. And we're going to multiply that by 2 times 10 to the -2nd. Okay? Well, both numbers are already in scientific notation. So again, I'm going to multiply the number parts. Okay, 2.4 times 2, well that's 4.8, times 10, and we're going to take these exponents and add them together. -6 plus -2 is -8. And now I'm going to check and say, is this number in scientific notation or not? Again, we know if it's in scientific notation if this number is between 1 and 10, which it is, and we're multiplying it by 10 to some exponent. So that's it. We are done on this one. It's 4.8 times 10 to the -8th. Okay, so part B. This is 2.4 times 10 to the -8th divided by 2 times 10 to the -2nd. So again, on this one, we're going to divide the number parts here because it's a division problem. So we're going to take 2.4 divided by 2, which is 1.2. So that's my first part, times 10. And then we're going to subtract the exponents. So it's going to be 10 to the negative 8 minus negative 2. Okay? Well, negative 8 minus negative 2, we need to change to an addition problem. That's negative 8 plus, and negative 2 changes to positive 2. Okay? And alright, and we're moving on to letter D here, so we'll slide this down a little bit. Make some room for letter D. We've got 4 times 10 to the negative 8th divided by 5 times 10 to the negative 2nd. So again, this is a division problem, so we need to take 4 divided by 5, which is 0 point, and then 5 goes into 48 times. Okay? So this is 0.8 for our first part, times 10 to some power. And again, with our exponents, we're going to have 10 to the negative 8 minus negative 2 power. Okay, which is the same as 10 to the negative 8 plus positive 2 if we change it to addition. So that's 10 to the negative 6th again. Okay, we just did one like that a little bit ago. Now, this number is not in scientific notation again because this first number is not between 1 and 10. So we need to adjust this so it is between 1 and 10. So we're going to move it so that it says 8 times 10 to some power. And when we move this decimal to the right, we have to make this exponent go down 1. Okay, now think about what down 1 is from negative 6. If I'm at negative 6 and I go down 1, that makes it negative 7. Okay, so this is the part where this gets a little tricky, is when you have to adjust it in scientific notation. And thinking when I move the decimal to the right, my exponent has to go down 1, and down 1 from negative 6 is negative 7. Whereas up here, oops, on this one, when I move the decimal once to the left, my exponent goes up 1, and up 1 from negative 10 to negative, or up 1 from negative 10 is negative 9. Okay? But that's it. We solved these the same way as we solved problems before. So we're going to perform the operation on the number parts, perform the operation of the exponents, and make sure our answer is correctly written in scientific notation. All right, and that's your lesson. Good luck on the homework.